Good day, everyone. Today I am going to discuss another topic with you, which is the geometric mean. We describe arithmetic means as the term between two non-consecutive terms of an arithmetic sequence. Similarly, inserting a certain number of terms between two non-consecutive terms in a geometric sequence is what we call geometric mean. Let's take this an example. In the sequence 1, 4, 16, 64, and 256, the three geometric mean between 1 and 256 are 14, 16, and 64. These are the numbers, or these are the terms between 1 and 256. They are what we call the geometric means. Let's take another example. Supposing you are to insert two geometric mean between 4 and 32. Again, if we are going to insert two geometric means between 4 and 32, 4 becomes our first term and 32 becomes our fourth term. The two geometric means becomes our second and third term. So the first thing that you're going to do, we have to analyze the problem first. What is being asked? So you're asked to insert two terms between 4 and 32. And then you are going to identify what are the given facts here. So the given facts here are 4, which is our first term, and 32 as our fourth term. And n is 4, since we have 4 terms. 1, 2, 3, and 4. Okay. And then what you're going to do is we are going to solve. How are we going to solve it? We are going to identify the formula that we are going to use in solving the geometric means. So what formula are we going to use? We are going to use the geometric formula in finding the nth term, which is a sub n is equal to a sub 1 times r raised to n minus 1, in which a sub 1 here is our first term, r stands for our common ratio, and n for the number of terms. Okay? Then we are going to substitute the given facts to our formula. So we have the given is our fourth term, which is our a sub 4 is equal to a sub 1 times r raised to our n there is 4 minus 1. Substitute. A sub 4 is 32 is equal to a sub 1 is 4 times r raised to 3, because we do not know the common ratio between the terms. So we are going to find the common ratio first before we are going to find the a sub 2 or the second term and the third term. So we have 32 is equal to 4r raised to 3 or cube. Then we have 32 is equal to 4r cube over 4. Over 4, we are going to divide both sides by 4 in order for us to find the value of our r. So we have r cubed is equal to 8. 32 divided by 4 is 8. So we are not yet done. We still have 3 in our exponent for r. So what we're going to do to eliminate the 3 here is we are going to raise r cubed to 1/3. So r cubed raised to 1/3. If we are going to raise our right side with 1/3, we are also going to raise 1/3 to the left side. So we have r cubed raised to 1/3 is r, or 3 times 1 is 3 divided by 3 is 1, is equal to the cube root of 8. So we have r is equal to the cube root of 8, which is the cube root of 8 is 2. Now we found the value of our r. It is just our ratio. Now let's go to solving our second and third term, or the means between 4 and 32. Since we have our common ratio, which is 2, we will now be able to find our second and third term, or the two terms between 4 and 32. By using the formula again, we will be able to find our two terms. So we are going to look for the second term. So we have a sub 2 is equal to 4 times our common ratio, which is 2, raised to 2 minus 1. Our n here is 2 because we are looking for our second term. So the n is 2. So a sub 2 is equal to 4 times 2 minus 1 is 1. 2 raised to 1 is 2. 4 times 2 is 8. So our a sub 2 or our second term is 8. And we are going to find our third term. For the third term, our n is 3. So a sub 3 is equal to a sub 1 times r raised to n minus 1, which is a sub 1 is 4 times our common ratio, which is 2, raised to 3 minus 1. So a sub 3 is 4 times 2 raised to 2, or 2 squared is 4. 4 times 4 is 16. So a sub 3, or the third term, is 16. So therefore, our geometric means between 4 and 32 are 8 and 16. Now we have our geometric sequence, which is 4, 8, 16, and 32. Now let's go to another example. So insert 3 geometric mean between 5 and 80. So what are you going to do first? You are going to understand the given problem. So you're asked to insert 3 geometric mean, between 5 and 80. And identify what are the given facts. We have, for the first term, we have 5, and the fifth term, which is 80. So we are asked to find the second, third, and fourth term. And our a sub 1 is 5, and our a sub 5 is 80. Now, this is how we are going to solve it. Okay, since we are asked to insert 3 geometric means between 5 and 80, the 3 geometric means will be our second term, third term, and the fourth term of our sequence. And our n is 5 because we have 5 terms. Then, before we're going to find the second, third, and fourth term, we have to know our common ratio first in order for us to find our 3 terms in between. So using the formula, a sub n is equal to a sub 1 times r raised to n minus 1. Substitute the given. We have 80 for our a sub n is equal to a sub 1 is 5 times r raised to 5 minus 1 will give us 80 is equal to 5r raised to 4. Divide both sides by 5 in order for us to eliminate 5 here. We are going to divide 5 by 5. So 5 divided by 5 is 1. So we have 1r raised to 4. 80 divided by 5, we have 16. So this is not yet the final answer because our r here is raised to 4. We need to have only r, or r raised to 1 only. So raise both sides by 1/4. So we have r is equal to 4th root of 16. So if you are confused with how this r is eliminated, the exponent of r is being eliminated, and how the 16 got into the 4th root, you may review your lessons about radicals, okay? So the 4th root of 16 is 2. Now we have our common ratio. Now it's time for us to solve for our second, third, and fourth term. Okay, to solve for the second term, we have a sub 2 is equal to 5 times 2 raised to 2 minus 1. We have 5 times 2 raised to 1, which is 5 times 2 is 10. So our second term is 10. And for the third term, we have 5 times 2 raised to 3 minus 1. So again, I would like to remind, you have to multiply first what's inside the parentheses and the exponent before you multiply the 2 here to 5. So 2 raised to 2 is 4. 4 times 5 is 20. Okay, that is our third term. And for our fourth term, a sub 1 is 5 times our common ratio is 2 raised to n minus 1, which is 4 minus 1. Again, remember your PEMDAS. So that is 2 raised to 3 is 8 times 5 will give us 40 for our fourth term. Now we have our three geometric means between 5 and 80. We have 10, 20, and 40. And our geometric sequence is 5, 10, 20, 40, and 80. Thank you everyone for attending our lesson this morning. God bless everyone, and remember Proverbs 10:4, a slack hand causes poverty, but the hand of the diligent makes rich. And Proverbs 6:6-8, go to the ways of the ant, O sluggard, consider your ways and be wise. Keep on practicing.